the set of all possible x values for a function. Domain. The set of all possible x values for a function. And underneath that, a range. The set of all possible y values for a function. The set of all possible y values for a function. Write that down. So domain is a set of all possible x values for a function. The range is a set of all possible y values for a function. Now what do I mean? Check this out. I trust everybody's got that? Let me take a picture here. Uh-oh. Let's try that one more time. So look at number 1 here on the upper left. Let's state the domain and range of this function. All right. So this function is just, there's just separate points here. I'll highlight them in blue since I'm a Dodger fan. There's 4 points. Actually, there's 5, huh? So last week we talked about domain and range. With this data here, again, earphones off, phones away. With this data, what are the possible x values? So I'm looking at my x-axis. What are the possible x values? Let's start from least to greatest. Least to greatest. So let's go -3. So yeah, -3. Is that with me? Comma. -2, comma. 1 and 4. There's your domain. That was easy. That was like ridiculously easy. How about range? The set of, we just defined range as the set of all possible y values, huh? The set of all possible y values at the bottom of your paper. So now I'm looking at the y-axis from least to greatest. Right, -4. Exactly, -2. You guys with me? How about right here? 0. I'm looking at the y-axis. I mean, I'm tilting my head here. 0, and then 3. And 5. The coffee hasn't kicked in yet. We're rocking and rolling. Is this a function? Argument. Hold on, we got the argument. I got you, Chris. You'll say the day if he doesn't. What input has more than one output? You're there. Real, say the day. Provide the argumentum. In Latin. Ooh. Vertical line test. It doesn't pass the vertical line test. Look at it. It crossed 2 points, so put no.
You can like do it either way, vertical line test.
Or the definition test, huh?
It doesn't matter.
It doesn't matter. So look at the definition test is what kind of echo sound I was getting at. The input of 1 has the output of 3, and the input of 1 here has the output of -2.
So how would you say that?
Well, there's an input that has more than one output. Because the function has to have exactly one output for every input. This input has two different outputs, 3 and -2. Or, like Munoz says, it doesn't pass vertical line tests. Let's rock and roll. Number 2. Anybody like rock and roll in here? Never mind. Here we go.
I don't know anyone that does this.
Boo. I don't know why my computer's acting so slow today. Give me a second here. There we go, there we go, there we go. All right, number 2, check it out. Let me get the number 3 going too, since we're on the topic here. Seems to be a pattern going on, isn't there? All right. So let's look at number 2. Now, we got a little pentagon going on here, a 5-sided shape, right? And our job is to find the domain and the range. So x can be here. I mean, there's points everywhere. Look at there's going to be points that involve fractions. It's not going to be as easy as that, where we just have individual points and we just name the numbers. That's going to be this is kind of interesting here. Look at, there's points all along here. I could keep zooming in. There's going to be like small fractional points. Right? These points are pretty easy to tell here, right there. So that one will be, let's see, that's going to be the input of 3 and the output would be 0 there. Yeah? What would the input be right there? Not this one. Help. Good try. 0 is the input, 3 is the output. Input there, what would the input there? -3, 0. So I'm just doing the corners first, just to get my mind around this problem here. It's going to be -2, -4. Yeah. Let's see, that's 2, -4. But x can be way more than these for the domain. X can be this, x can be right here, right? This point. So this point right there would be, let's say that's like a -0.75. And I go up 2, right? This is going to get messy. So how am I going to state every x value for this graph? That's the question. X can be here, here, here. I'm talking about points from here to here. There's literally an infinite amount of points, because you can get smaller and smaller fractions. Zoom in on it, and you get smaller and smaller. Even right here, all these points. How am I going to? There's no way. We don't have enough time to be listing all these even fraction points there. So in other words, say right here, that point. That point is, let's see, that's the input of 0.5, because I'm not at 1 yet. Here's 0.5, and I go up about 2.5, let's say. Well, right here. That's 1.5 approximately, just eyeballing it, and I go up 1.5. Are we about to start listing all the fractions with the whole numbers? Heck no. I'm hoping you guys see the problem now. How the heck are we going to state the domain, and how are we going to state the range when there's a bunch of numbers in between a bunch of numbers, as opposed to right here? That was easy. That was cakewalk. Any ideas? Extra stamp. We'll start in the ante now. How the heck am I going to state the domain? How about this? Ataya, hit it. Save the day. Oh, okay, so -3. So x can be -3 and then +3, huh? So any number that, so -3 through 3, huh? Like that? I kind of like your idea. Notice what he's thinking. He's saying, look, x can be any number from here all the way over here. That includes all the fractions. So he's on to something. I trust you see where he's going. So x can be something between here and here. It can't be anything outside that interval. There's no x values that are past -3 over here. There's no x values that are past +3 over here. Just looking at x values. Every value here on this pentagon, every x value is in between -3 and 3. So you're onto something. The question is how the heck we state it. 2 stamps. 2 stamps. Did we? I think Rios is right. Some of you Math 2 students should remember this. Let me pause this while I pour some coffee. So, Ataya, that you're on the right track. He knew the boundaries had to be -3 and +3. We're describing x when we describe the domain. X has to be bigger than, look at, the Pac-Man always wants to use bigger. X has to be bigger than -3 or equal to -3. There it is. Okay, there's an endpoint. But less than or equal to +3, there's the other endpoint. We're rocking and rolling. How about domain? Or range, rather. What variable am I describing for range?
Y.
The y. So put y here. What's the lowest value y can actually be here? You're awesome. Look at it. So put -4. Y can equal -4 or be bigger than it. But at the same time, what's the maximum y value? Y can be equal to 3 or less than 3. We're rocking and rolling. There's your range now. So you're stating all the possibilities that y can be. It can be bigger than -4 or equal to -4, or less than 3 or equal to 3. Think of the logic here. Is this a function? No. Vertical line test doesn't pass. You guys doing good. Last one for the day. I'm not going to do all of them. Just going to do one more. Question number 2. This one's funky. This one's weird and hard. Okay, so whenever you see an open circle, does anybody remember what it means? Open circle?
Oh, it's not equal.
Right, it's not equal to that number. So x cannot be -4, but anything bigger than -4. But it's never going to equal to -4. So notice this function, it starts at anything bigger than -4 and then stops at 1. It's not defined at all in between 1 and 3. In other words, there's nothing x can be between 1 and 3, but then it kicks in at 3 and it goes on forever. The arrow means it goes on forever. So, would someone please, let's go Ekusa. Would someone please give me what x can be between here and here? So, what's the boundaries here? What's the furthest most point over here? We'll write -4. Can x equal -4? No, so put just x can only be bigger than -4. Can x equal 1? Yeah. It can equal 1 and be less than 1. Then put n. That's not all x can be. Look at it. We skipped some area. Now what else can x be? How would I describe this part? This goes on to infinity. From here to here. So we covered this part. X can be bigger. Look, but it's never going to be equal to -4. But less than 1 and equal to 1. That's this part. We covered that part. Now how are we going to cover this? How can we state what x can be here? X can definitely be 3, right? What else can x be? What would all this be? Well, infinity would be over here too. Well, here's positive. Well, no, because look at 1 and 2 is still part of positive infinity. It's not part of it. Look at 2 is part of positive infinity. So how do I describe all these numbers here? All real numbers would be everything. You're on the right track. I just want all these real numbers here, from here to here. So from here on, from 3 on, how would I write that mathematically? Everything 3 and bigger. Extra stamp. From here, that way, forever, to infinity and beyond, in Buzz Lightyear. X is greater than or equal to 3. There it is. X is greater than or equal to 3. Remind me at the end, you got the extra stamp. So look, we covered the domain. X can be anything in between these two numbers and anything bigger than 3 or equal to 3. X is bigger than 3 or equal to 3. So I put a big N in between, N with both of these. Last one is do range. All right, so look at the y-axis now, from lowest to highest. The lowest y value would be 1, huh? So I know 1's going to be involved. What's the highest y value? Infinite. So how would I describe y values now? Can y be 3? Yeah, look at y can be 3 right here, not over here though. It can be over here, so y can be 3. Y can be anything bigger than 1, so how would I state that? Y can be anything bigger than or equal to 1. Well, all real numbers would be these two. It can't be, it only starts at 1 and goes forever that way. So it starts here and goes forever that way. So how would I describe y? Thank you. So put y is greater than or equal to 1. Y can be any number bigger than 1 or equal to 1. I mean, look at it for yourself. Study the picture and see how this logically it makes sense. Y can be any number bigger than 1 or equal to 1. You can see it from the graph. Is this a function? It is. It passes the vertical line test. Any vertical line will only pass 1 point.